Hello students, let's move on to the next topic, which is called as identification of concave polygons. Identification of concave polygons. In this topic, let us see what are the different types of identification algorithms we have in order to identify a concave polygon, right? As we already know, what is a concave polygon? A polygon where any one of the interior angle is greater than 180 degree, right? So we call it as a concave polygon. So what are the different ways we can identify the concave polygon? So we have two algorithms here. Let us discuss the first algorithm, right? Identification algorithm 1. Identification algorithm 1, right? So the first algorithm says that we can identify the concave polygon by calculating the cross products. By calculating the cross product of successive pair of pairs of edge vectors, right? So this is the first identification algorithm. We can identify by calculating the cross product, right? We have already studied that there are two types of vector products, dot product and cross product. So here we are including the cross product of successive pairs of edge vectors, right? So after calculating the cross product of the vectors, if at all we get a combination where the products are positive, the result of the cross product is positive and negative, right? We have a combination of both positive and negative, then we say that it is a concave polygon. Then it is called as concave polygon. If I have the result of my cross product as a combination values of both positive and negative, then such a polygon we call it as a concave polygon. If at all the result of my cross product is of the same sign, right? So same sign in the sense, if all the values are positive, else I get the result as all the values as negative. If at all the result of my cross product is all the values are positive, else I get all the values are negative, right? So then such a polygon I classify it as convex polygon. This is the first type of identification algorithm, right? So what it says that we can identify a polygon as a concave or convex polygon by calculating the cross product. Cross product you have already studied, A cross B. This is what we mean by cross product. By calculating the cross product of what we are calculating of successive pairs of edge vectors. Every edge should be identified by a vector. Then we have to take the cross product of such vectors, right? So in our vectors we have dot product and we also have the cross product, right? So when I do this cross product and I obtain some result, and the result consists of both positive values and negative values, then that particular polygon I classify it as a concave polygon. If the result of my cross product is all positive, all the values are positive, else all the values are negative, then I characterize such a polygon as a convex polygon. This is the first algorithm. Let us see it with an example. I will be considering a polygon here. This is my coordinate axis, x and y coordinates, right? So consider a polygon. Here I have vertex 1, vertex 2. This is my edge 1, right? So again from vertex 2 to vertex 3, I have an edge 2. Again vertex 3 to vertex 4, I have an edge 3. This is my edge. Again vertex 4 to vertex 5, I have an edge. This is my E4. again vertex 5 to vertex 6 I have an edge, this is E5. Again vertex 6 to back to vertex 1 I have an edge, this is called as E6, right? So like this my polygon is divided into 6 vertices here, right? As you can see, this is the shape of my polygon. This is my polygon actually what I have drawn there, right? So it has 6 vertices, vertex 1, vertex 2, then I have vertex 3, this is the shape, sorry, vertex 4, then vertex 5 followed by vertex 6, right? So this particular polygon is represented by making use of the edge vectors, right? So every edge, what is an edge? An edge is nothing but a connection between any two vertices, right? So between V1 and V2 I have E1, same way I have E2, E3, E4, E5 and E6, right? So we have to find the cross product of these edges, right? So I will be finding cross product of successive pairs of edge vector. Successive pairs means what? E1 to E2, E2 to E3, E3 to E4, E4 to E5, E5 to E6 and E6 to E1, right? So let me write the successive pairs first. E1 to E2, the next pair will be E2 to E3, third pair is E3 to E4, fourth pair is E4 to E5, the next pair is E5 to E6, then I have E6 back to E1, right? So this is how I will be finding the cross product of my edge vectors. So if the result of this particular cross product is sum is positive, right? So we can say for example, E1 cross E2 is greater than 0. So any number which is greater than 0, I call it as a positive value. Any number which is less than 0, I call it as a negative value, right? So E1 cross E2 is greater than 0, so positive. E2 cross E3 also I will get it as positive. Say E3 cross E4 is lesser, right? This is greater, this is lesser, this is lesser, right? So like this, after multiplying the edge vectors, I will get different types of results, right? So if I get a combination of both positive and negative values, I categorize this polygon as a concave polygon, right? So this is my identification algorithm 1. By finding the cross products of successive pairs of edge vectors, right, and seeing the result, if the result consists of both positive and negative values, we call it as a concave polygon. The second method of identifying a concave polygon is by using extension lines. Second algorithm to identify the concave polygon is by using the extension lines. So what do you mean by an extension line? Say for example, I take any diagram, right? It can be any diagram like this. I want to say that this is some 3 centimeter. I will draw some line, right? So such line, we call it as extension lines. This line, what I am taking as an extension of the previous one, right? So such lines we call them as extension lines. So the algorithm says if some vertices are on one side of the extension line, if some vertices are on one side of the extension line and some are on the other side. If some vertices are on one side of the extension line and some are on the other side, then such a polygon we call it as concave polygon. Right? So that was an example for triangle is a convex polygon, right? So let me write one concave polygon. If I take this concave polygon, right? So if I take extension lines, if some vertices are on one side of the extension line and some vertices are on the other side of the extension line, right? So as you see here the extension lines if I take the extension lines, right? So if I take these extension line, right? So some vertices are there on one part of the extension line, right? And some vertices are there on the other side of the extension line, right? So like this, it is not the same. They are not on the same side. If you take a triangle, all the extension lines are on the other side, right? That is towards outwards of the polygon or outwards of the vertices. This extension line is also outwards. This extension line is also outwards. This extension line is also outwards. And all the vertices are on one side of the extension line. That is why it is convex, right? But for concave, we have our extension lines where some are on one side, some vertices are on one side of the extension line, whereas some vertices are on the other side of the extension line, right? So these extension lines are going like this, right? So if I take this also, this is also going towards this is also going towards this, right? Whereas the extension line of these vertices are going this way, the extension line of this particular edge is going the other way, right? So some vertices are on one side of the extension line and some vertices are on the other side of the extension line, right? Then we categorize this type of polygon as a concave polygon.